Okay, so today we're going to be doing error handling in Python. The rest will catch us as we proceed, or we can give them the next 3 minutes before we begin. Okay, the rest will meet us as we continue. As I was saying, today we're going to be covering Python error handling or just error handling. And this is the last installment in the lessons of Python. So this is the conclusion of what we have been covering with Python. Before the next week, we proceed to other concepts in relation to Django. So we're going to be starting Python Django from Monday. So this is the last installment of Python error handling. So essentially, error handling is about dealing with errors that occur when you're writing your Python code. So with error handling, we'll start by the definition of errors. So errors in Python are usually issues that are in your code. They prevent this program from running the way you intend it to be. That is what errors are. And these errors can occur in either of the two stages. They can occur during the parsing or interpretation phase of the code, and they can occur during the compilation of your code. So they can occur either of those times, either during the parsing or during the interpretation or the compilation of your code. So we have several types of errors that we are going to be looking at in our class today. But essentially it's just about errors. So we are going to be looking at introduction to errors and exceptions. whereby we will begin by definitions of errors, exception. We will differentiate what an error is and what an exception is. We're also going to look at the different types of common errors that you're going to encounter. We're going to look at syntax, type error, key error, name error, and attribute error. And we're going to have a look at basic exception handling, whereby we will see how to integrate the try. We also have the except, else, and also finally blocks, which are going to be using to catch exceptions and handle them. We are also going to be looking at how to handle multiple exceptions and how to use arrays to throw exceptions in your code. That is what we are going to be looking at today. And as we had begun with the definition of what errors are, and we've said that errors are issues in the code that prevent the program from running. They usually either occur during the interpretation phase or the parsing phase, or they can also occur during the compilation phase. And there are several types of errors. We have something like syntax, which means that your code is violating the grammar rules of the programming language. We have other kinds of errors. And as you can see, we have a new term here called exceptions, right? Exceptions are also just errors, but these are errors that are detected during the execution of your program. So if you had written your few lines of code and then the syntax was correct, like there were no errors grammatically, but when you're going to execute this code or this program, an error that may occur when you attempt to make your code work. And unlike other types of errors that may be prevented when you try to run the program before, these exceptions, they occur during runtime. After you've just run.
Bobby,
Yes.
sorry to cut you short, but your
Yeah.
screen is kind of minimized. It's so small we can't see it. Maybe you can try maximize it. Okay, you yes, you're maximizing it, but is it is it on max screen? Because we're
Yes,
only seeing like a quote of it. It's,
it's on Mac's screen. It's just that the slides are a bit large,
okay,
so
okay, okay.
I've tried to zoom it.
Okay, zoom in then a bit. Yeah, we can see them now, but yeah, better.
Okay. I'll also share others as we continue. Don't worry.
Okay.
Mm. I was explaining. Also, I was explaining that we have another term here called exceptions. That on the other hand, exceptions are also still errors, but these are errors that are detected during the execution of a program. Unlike the normal errors, the syntax errors, they are detected even before the program begins to run. We saw the definition of syntax where we say that. What did we say about syntax, if you can remember?
It's how we our mode of naming. That's how simple I can put it. How we structure say variables, like
Yeah.
your method, the way you start with the def, then the method, then the it has to it must have the colon.
Yes. Thank you very much. So that is what a syntax is, and that is one example of the kind of errors that we are speaking about. So those kinds of errors, they are detected even before the program begins. Like if you make a mistake in the syntax, the code won't run. It will detect that there's an error and it won't run. So that is an example of an error. On the other hand, with exceptions, these are also errors, but these are not detected before like the other kinds of errors. These are detected during the execution of your program. Only when you are running your program, that is when you will encounter these kinds of errors, which we call exceptions. Even if your syntax is correct, you can look at your code syntax, you see I've written it correctly, but you see an error will occur when you attempt to execute this code, this statement, or this expression. So those are what we call exceptions. They are detected during the execution. And unlike the other kinds of errors that like syntax errors that prevent the program from starting, these exceptions occur during runtime and do not necessarily cause the program to terminate immediately. Your program will still run, but it won't terminate immediately like the way it will with other kinds of errors. Okay, so Python usually raises what we call exceptions when it encounters certain situations where it can't handle the normal flow. Like, you know, with Python, it has a flow, the way it follows your code from the top continually. So these kinds of exceptions occur when it cannot follow the normal flow of the execution. Such an example of that is like when you try to divide a number by zero, it will give you a zero division error. That is what we call an exception, whereby yes, it will run, but you cannot divide a number by zero. We have others like trying to access an undefined variable. It will also give you a name error and so forth and so forth. And Python has ways of handling these exceptions. We're going to get to that shortly. So we said we are going to introduce what errors are and what exceptions are before we go to the examples. There's something that I've mentioned about interpretation phase, compilation phase, where these kinds of errors occur. So let me explain on that a bit. Then we go to a few examples. So we use VS Code as our main IDE. We call it an integrated developer environment. We say VS Code is an integrated developer environment. But some of these languages have two phases, a compilation phase and an interpretation phase. So in the compilation is the process where we are converting our source code, which we have written in this programming language, into a machine code which the computer can execute. By default, the Python interpreter performs all these steps for us. So when we write our Python scripts, the Python interpreter reads the entire script, then it converts it to the bytecodes, the code that can be understood by your machine. And then during this compilation phase, whereby it's reading your entire script, because I've said like Python has to compile it all, so it has to read your entire script. The Python interpreter has to read your entire script before it converts it. So during this compilation phase, that is where syntax errors usually occur. They're detected. These are the errors that are detected before even the program starts running. Okay, so those are the kinds of syntax where syntax errors are detected. Now this other thing we call the interpretation kind of phase. So after now your code has been compiled into this bytecode, this bytecode that can be understood by the machine, it now has to be executed, right? By this Python interpreter. So this is the interpretation phase. This is where Python will run your code. And during this interpretation, it performs whatever you have instructed it. If you've said in your code that do this, do this, do this, it will perform all of those actions. So this is where you may encounter runtime errors or this exception. This is where they may occur. So we have runtime errors or exceptions. This is where they may occur. Up to there, are we together?
Yes, yes, we are together. Okay, on the point of the compiler, the source code, you
Mhm,
said, I, what did you say? You said we write our code, then it gets compiled by now Visual Studios, right?
mhm.
Then you said something after that. I didn't understand it quite clear.
Okay, when we are writing our codes, we are writing it using a programming language. So we call these programming languages like Python, JavaScript, and so forth. We call them high-level programming languages. So we write our code in these high-level programming languages. But machines or computers, they don't understand these high-level programming languages. They usually interact using low-level programming languages. So when we write our code, the interpreter, the Python interpreter, has to compile this code in, and then after it compiles, it reads first your entire code, and then it converts it to the what we call bytecode, the low-level representation of your code, so that the computers can understand. So while it is reading during this compilation phase, that is where the kind of the errors, syntax errors are caught. And this happens before you run your program. That is where some errors are caught. Then we have the second phase. This is where we call the interpretation. After it has, from the high level language that you have written, it has transformed it to the low level language that the computer can understand, right? Now it has to execute this code. So after it has been interpreted in the first phase, now in this second code, in this second phase, after it has been compiled in the first phase, in this second code is where it's interpreted. So it will execute whatever you have said in your code. So if you have said scrape the web and do this, so it will perform all those actions that have been written in your code. It will perform all of those actions, and this is where exception errors may occur.
Okay. So when you run your code, that's when the interpretation happens. The
Yes,
compilation just happens when you're writing the code, even before running it.
yeah,
Okay, thank you.
thank you. Okay, that is about the interpretation and the compilation. I'd say that we have what we call errors and exceptions. We've already seen the definition of errors and exceptions. We have been able to differentiate between errors and exceptions. Now we want to have a look at common types of errors. Before we proceed, we want to have a look at common types of errors. Right? We have seen the definition. Now we are having a look at the common types of errors. We are going to begin with the syntax errors. Right? That is what we are going to begin with, what we call the syntax errors. And as we had said, in the context of programming, syntax are the set of rules that define how your code must be written for the computer to understand it and execute it. We have seen about compilation and interpretation. So these are the set of rules. Like when we are doing CSS, we see that this is how the CSS syntax is. When we are working with Python, this is what we see. This is how the Python syntax goes. Whenever you are learning a new programming language, the first thing you have to learn is the syntax of that language so that you can continue with other concepts. So syntax refers to the set of rules that define how a code must be written for the computer to understand and execute it. So it's just like grammar or the structure. You remember when you were learning human English, we were taught how to use the correct punctuation, things like adjectives, subject verbs, agreement, and all of that. So in programming now, it's what we call programming syntax. That is what dictates how we must structure our code. And it is this syntax is important since it shows the correct order of how things go, correct placements, and the way variables are defined, and how functions are called, right? So, for example, in Python, if you want to, let's say, print hello world, right? Let me zoom in a bit. I hope that is clear, right? So this is how, if let's say we want to say hello world in Python, we are calling a function in Python, we use the print, we said that, and we use parentheses around our arguments, right? So if I say print, then we use the parentheses or the brackets, and then quotation marks inside, and then we say hello world. You see, now that is the correct syntax of Python. If I run this code, it will run the way it's supposed to run. If I say, you'll see it will give us the output hello world, right? So that is a code that is in correct syntax. But what if I miss something in my code? If I miss something in this code of mine, I will get what we call a syntax error. For example, let's assume that I forget to put the closing bracket like that. And we are going to say print hello world. If I try to run this code, you can see down here what is happening. I'm being told syntax error, incomplete input. Right? That's what I'm being told, that this is a syntax error. Essentially, it is telling me that I am not using I'm not using the parentheses completely, or I have not written this piece of code using the correct syntax. For instance, I have missed a closing bracket. That is what a syntax error essentially is like. Because Python, the interpreter is expecting to have a closing paragraph, a closing bracket on the end of this code that I've written. So for it to be complete, without that, it cannot even run it. It will tell me that this is a syntax error, there's an incomplete input in my code. That is what it will tell me, as you can see. If I put the paragraph and then I try and run it again, you see, it runs very well without any issue. It runs very well without any issue. That is what we call a syntax error. It's an error whereby your code does not follow the set of rules that define how that code is supposed to be written. And by now, I think we all know the syntax of Python. So if you miss a bracket, if you don't do the indentation correctly, if you don't define your variables, all these are examples of incorrect syntaxes. For example, let's look at with indentation. With indentation, right? We want to indent our code. So we are going to say if x is greater than 0. So if x is greater than 0, right? Then if x is greater than 0, what do we do next? We say print maybe a positive number on the next line. So you can see it has already indented for me. So we say print positive number. You can see there's a space between where the line begins and where my print statement is, which means this has been indented correctly. That is the correct syntaxes. So in Python, we use indentation to indicate our blocks of codes. So this indentation, you will see it most of the times when you are writing if functions or other functions, you will see it coming automatically. And if maybe you are writing your code without looking at this indentation, you will find yourself sometimes having missed the indentation, and this will be an incorrect syntax. So for instance, if I clear this space where the print is, and I try to name this function, you'll see down here it is writing for me indentation error, expected an indent block after if statement, right? You see what it's telling me. So this indentation is also an example of a syntax error, because we had said syntax is the set of rules that define how a code must be written. So if we are writing a code, an if function, then we need to also obey the rules whereby that we need to have indentation in our code for its syntax to be correct, right? Up to there, I hope we are together. Another example is when we are defining variables. So for example, if we say name equals, let us say Brian, name equals Brian, right? You can see I've used the correct syntax whereby I have defined the variables. I've said that our name is Brian, which is a string. What if, and you see with a string, you have the quotation marks. What if I remove these quotation marks and we say name is Brian? You'll see it will tell me name error. Name Brian is not defined because it's in our syntax, we have not followed the rules of how we're supposed to define our variables. I hope up to there we are following each other, because the name is it's supposed to be a string, so it doesn't know what name I'm referring to without the quotation marks. So those are the examples of what we call syntax errors. Right? Those are examples of what we call syntax errors. Up to there, we are okay with syntax errors. Yes? That if you encounter a syntax error, you understand that, okay, this is a syntax error that I'm encountering, and I know how to handle it. Next, we are going to move to type errors. We're going to understand these things that we call type errors. These things that we call type errors. Next, we're going to have a look at what we call type errors. So, with type errors, these are errors that occur when the operation or function is applied to an object that is not of the appropriate type. So when Python tries to perform an operation on a value that is not compatible, that is when you get what we call a type error. So if you try to perform an operation of incompatible data types, for example, if you try to add, let's say you're adding an integer, a number 1 plus a string, 1 plus hello, or 1 plus, the example we had used the name Brian, 1 plus Brian. that will give you a type error because these data types are not incompatible to perform the operation. If it was an integer plus an integer, that would work. But now you see you're using an integer and a string. You're using a number and a word, trying to add them together. So trying to attempt to add a string and an integer, and that will give you a type error. Another example that can give you a type error is when you are passing arguments to a function that are of the wrong type. For example, if you're trying to pass a string where an integer is expected, that will give you a type error. And you're calling methods. So there are certain calling methods that are not available for certain types of objects. So you cannot, if you say you want to call a string on an integer or a list on a string, that will bring what we call a type error. For example, let's have our first example here. If we say we are trying to add a string, for example, we say result equals, right? We say hello, then we say +5. We see something like this. So here we are trying to add a string plus an integer, and these two are of different data types which are incompatible. So we cannot add a string to an integer. Python cannot, what do we call it, concatenate a string and an integer. So what will happen, it will raise what we call a type error. So if I try to run this, you'll see here, it's giving you a type error saying Python can only concatenate a string, not an integer to a string. So it can concatenate a string to a string or an integer to an integer, but not a string to an integer like what we are trying to do. So that gives us a type error, right? That is what we call a type error. That is one example of what we call a type error. When you try to do an operation with incompatible data types, that is what you get. Another example is that you can get a type error is when you are passing arguments of the wrong type to functions, right? So some functions expect specific types of arguments. So if you pass the wrong type of argument, Python will realize this and it will raise what we call a type error. For example, if we say num, for example, let's create here. If we say num equals to, we say integer, then we say hello. Inside there we say hello. Num equals to int, and then we say hello, like this. So here the int function, excuse me, the int function expects a string that can be converted to an integer. So for example, if we had written there inside that bracket, if we had written 1, 2, 3, it will be okay because it will be expecting that string to be converted into an integer. But here we have written hello, and this is not a valid integer. So if we try to run this code, it will tell us this is a type error. Let us try and run it, we see. Error. No. It's supposed to tell us that this is a type error. That is the kind of message it's supposed to give us, saying that this is a type error as none equals. Giving a value error. It's okay, no problem. I'll figure it out. So, but this is what we essentially what a type error is. So a type error is when you try to either do an operation with incompatible data types, or when you try to pass arguments of the wrong type or to the wrong function. And another way that you can encounter this, what we call type errors, is when you are calling methods or your attributes are of the incorrect data type. So when you are calling methods or your attributes, you're calling attributes of incorrect data types, you can encounter what we call a type error, right? For example, if we say, if we try to do a small exercise, we say define addition, right? We are trying to say define add, then we say A and B. That is what we want to do. Right? We want to add A and B. So we want it to return A plus B, right? We want it to return A plus B. And then if we go to the result, we say result equals add 5, right? If we say something like this, result equals add 5, what we are doing here is that this function of add, it expects two arguments, argument for A and an argument for B, right? But we have given it only one argument. So Python will give us what we call a type error because we are not it's missing this one argument. We are not passing the correct number of arguments. So that is what we call a type error. We can move on to the second one, what we call, the third one, what we call a name error. Up to there, we are together. I'm not leaving anyone behind, right? Okay, I see thumbs up, so I believe we're together. So what a name error is, a name error, it usually occurs when you try to use a variable or when you try to use a function name that has not been defined, okay, or is not in your code. So that means Python cannot find a reference to this name or this variable. That is where you encounter a name error. So you try to refer to something that is not there or something that has been misspelled. That is when Python gives you a name error. So with name errors, if you're using maybe a variable that has not been defined, you can encounter this name error if you misspell a variable or a function name. So if you're trying to refer to a variable or a function name and you have misspelled it, maybe you wrote name up there, and down here you wrote NAM, and up there you wrote NAME. So you see that misspelling can lead to what we call a name error. Another thing that can lead to what we call a name error is when we are using variables outside their scope. We'll see this in example. So usually when I want to for example, usually when I want to maybe call a function, I say x equals to, maybe let's say Nairobi, right? And then I can say print X, right? And when I run this, it will give me the name Nairobi. Okay, so when I've given my variable X a string name called Nairobi, and I want to print what X is, and it gives me the name Nairobi, right? What if I don't define this X, what X is? And now I try to tell it print X, right? So if I tell it that to print X, let me clear this. This had already, okay. Print Y. Yeah, this is what I'm looking for. You see, it will give me a name error. And it tell me Y is not defined in this line. So Python will give me a name error telling me that I've forgotten to declare my variable or I've made a typo, right? So let's say we say Z equals to, let's say Zambia, right? And I say print, and then I misspell. Instead of writing Z, I write double Z, right, like that. I write double Z instead of the single Z that I had named my variable. When I try to do that, it also tell me name error. Double Z is not defined. You get? Because it means that I've either misspelled, made a typo, or I've not defined this variable that I'm trying to call. That is an example of when a name error will occur, right? Another one is if I misspell this variable or function name. So as we had seen before, if I say name equals, we say Kenya, name equals to Kenya, and then I come here, I say print, and then instead of writing name, I make a mistake because I'm typing fast. I make a mistake and I type NMAE instead of the word name. You see, that is because I've made a typo. So it will tell me the whatever I'm trying to do, that variable is not recognizable. So I check if I've written the correct variable name or the function name before I proceed. Okay. Another one is if you use a variable outside its scope, that is another thing that can cause you to have what we call a name error, right? So far up to there, I hope we are together. In conclusion, you're going to see what these errors they are, why they're important in knowing what these errors are. So far, we have seen how syntax errors look like or when they occur. We have seen what type errors look like or when they occur, and now we have also seen what name errors are and how they occur. We are moving to what we call index errors. You remember when at the beginning when we were learning Python, we were told about indexing in Python. Can you remember that?
Yes.
Yes. So with indexing is trying to access a specific index in a sequence. Okay. So an index error in Python occurs when you try to access a specific index in a sequence. For example, you have a list of names and you're trying to access something specifically in that list, a specific index in that list, and you're not accessing it correctly. So you may get an index error or in a tuple or a string. So if you're trying to access an index in that sequence that is out of range, so you're trying to access an element or a position that does not exist in the sequence, that is when you'll get what we call an index error. So accessing an index that is beyond maybe the last index. Maybe the index has 3 positions and you go to the 4th position or the 5th position. So accessing an index that is beyond the last one, you can get an index error. You can also get an index error if you are using a negative index that does not correspond to a valid element. So negative indexes or indices allows you to access elements from the end of a sequence. However, if the index is maybe too negative that it is not possible to be at the end of your sequence, it will cause what we call an index error. And if you're looping between the lengths of a sequence, you can also get what we call an index error. We are going to see an example of this. Okay, first of all, let's say a list equals. Then we say 1, 2, and 3, right? Let me clear these other outputs. Right? So before we proceed, let's see if you still remember which index is number 1 in this list of ours. Yes, I hear someone has raised their hand.
0.
Yeah, yes, that is correct. Number 1 is at the 0 index. So I can see you can remember. So this will be 0, this will be 1, this will be 2, right? That is how the indexing in Python works. So here we don't have a third one because this is 0, 1, 2. So if I try to tell it print a list index number 3, right? If I try to tell it to print that, because that does not exist, it will give me an index error. As you can see, index error, list is out of index range, because here we don't have a third index position, we only have 0, 1, 2. If maybe we had we say 4, now that is the third, 0, 1, 2, 3. If I run this, it will print 4 because 4 is now in the third index position. But now before I did that, this is what we had, and when I run that, it will give me an index error telling me that in this list the index that I'm requesting is out of range. That is how we come across what we call index errors when we are trying to access a range of index that is out of an index that is out of range. That is when we encounter what we call an index error. Another way that we can encounter this index error is when we get a negative index that is out of range, right? If maybe in this list of ours we had 10, 20, 30, let's say 10, 20, 30, right? And then we try to access a negative index at number, let's say negative index 4, right? We say here negative index 4. Let us try and run. You see, it will give me an index error saying that list index is out of range, right? Trying to access a list index that is out of the negative index range. So you remember in Python we can use negative indices to access elements that from the end of the list. Instead of starting at 0, 1, 2, we begin at -1, -2, -3 as we continue. Now starting from the last element instead of starting from the first like we had seen before. So where the last number, which is 30, will be -1. Then the second one to the last, which is number 20, will be -2. And the number 110, the third to the last, will be -3. Since we don't have another number as we continue, we don't have another negative index that we can say like negative index 4, because we only have 3 elements in our list. So when we're trying to access the negative index 4, it will give us an index error because there are not enough elements for us to get a -4 index. Okay, up to there, I hope we are together. Another way that we can encounter this negative index error is when we are using, we're trying to loop our lists, and then we use a loop beyond the length of our list. So for example, if we say for I in range 5, yet our list has only 3. You see, we are looping what is beyond our list. Let's try and do that. We see. So we have our list which has 1, 2, and 3. Oh, let's just create another one. Right, so we have our list. Right, so it has 1. It has 1, 2, and 3. Right, so we say for I in range. So this range, it needs to be within whatever is in our list. So if we have 3 in our list, it needs to loop through those 3. If we have 4, it needs to loop from only those 4. But if we say for I in range 5, so we try to loop it. So we say for I in range 5, for I in range 5, right? And then we say print list, and then we want to print this I. Oh, I should not have updated it. Okay, we say print. Okay, want to print this list of ours, but we want I specifically, right? So we are trying to loop to arrange that exists that exceeds what we have. You see down here, it will give us an index error telling us that this list index is out of range. So we cannot get a random out of 5 because we only have 3. So you see, we are getting an index error there when we try to loop throughout our list. So that's another instance whereby you can encounter an index error. Up to there, I hope we are together. So far, we have seen what a syntax error is and how it occurs. We've seen what a type error is and the examples of how it occurs. We've also seen a name error, and now we've concluded seeing what an index error is and how it occurs. We want to look at the last 3, the key error, the value error, and the attribute error. That is what we want to move on to next. So we'll begin with the key error. We'll begin with the key error. So in Pythons, we have what we call dictionaries, right? And dictionaries are what we store data in Python, right? So we store this data in form of what we call key value pairs. So a key error occurs in Python when you try to access a dictionary using a key that does not exist. Okay, so as we've said, in Python, dictionaries store data in the form of key value pairs. So dictionaries are what we call key value pairs. And if you try to access a key that's not a part of that dictionary, Python will give you a key error, right? So trying to access a key that doesn't exist in your dictionary, Python will give you an error, or using a variable as a key, and this variable has not been initialized. So Python will also give you a key error, and sometimes we have typographical key errors that may occur. Want to see an example of what we call a key error? So key errors occur when these dictionary keys have not been found. So let's do an example of that. So we say dictionary equals to, we say name, right? And then we say this name is Brian. Let's use Brian. Okay. And then we only have the key in our name, which is name. The key in our dictionary, which is only name. Now we want to access a key that is not in our dictionary. We want to access age. Okay, so we say print. In our dictionary, print age. Right, so we want to print a key value or a key that we cannot access, which is called age, which we've not created in this example of ours. So when we try to run this, because age is not in our dictionary, it will give us a key error because age is not represented in the dictionary. You can see it gives us what we call a key error. It tells us, it just tells us even age because itself it does not understand why we are trying to access age when its key does not exist, right? So that is not present in our dictionary. We only have name. So if we said we wanted to see only name, you see it will give us Brian because Brian is in our dictionary. But if you try to access age, it will just give us that key error because that does not exist. Okay, that does not exist. It's a key error. So trying to access an non-existent key, right? That does not exist. We can even take it further. Maybe now we say age exists. Okay, so here we say age exists, right? So we say age how old will we say? Let's say 30, right? Right. So when we try to access age right now, it will give us that 30. But let's try access a key that does not exist. Let's say address. Yeah, how is address? Address. Yeah. If we try to access that, it will also give us a key error because the key for address does not exist in our dictionary. So it will give us that error. So that is how we are getting key error because we are trying to access an existing key. If we try to maybe use a variable as a key and we have not defined this key in our dictionary, it will also still give us a key error. If we have some typographical error, because you remember Python is case sensitive. So for instance here, we've used name with a small n. So if we try to access it and now we use capital N when we are typing name, because this is a typographical error, it will still give us a key error. Even though it is still the same thing, but now you see here we did not use the capital letter here, but here we used a capital letter. So that is what another way that we can get a key error when you have typographical errors in your key name. So Python as always, is case sensitive. So always be aware of that so that you can avoid such. The other one that we were to go next to is value error. So far up to key error, I hope I have not left anyone behind and we are together as we proceed to what we call value error. With value error, a value error in Python usually occurs when a function receives an argument of the correct data type but with an inappropriate value, right? So you have an argument of the correct data type. For example, we'll see an example shortly, but with an inappropriate value. So for example, we are trying to give an integer, but we are using a string. You see, it's a correct, right? But it's an inappropriate value. That will give us a value error because Python is expecting a specific value within the range that can be in that kind of data type or format of that operation. But if it receives something else that doesn't make sense for that operation, it will give you a value error. And you can encounter a value error if an incorrect data is passed to a function, when you convert an invalid string to a number, or when passing invalid arguments to a function. That is when you can encounter what we call a value error. So in our example here for this one, for example, we use the int function, which expects a string representing numbers. So for example, if we use the int function here and we say 1, 2, 3, this is okay because this is what this int function is expecting, right? But if we pass something like hello, here, which is not a valid number because the int function stands for integer and it expects the value there to be an integer. So here we're going to be getting a value error because Python cannot convert a string which is hello into an integer. So you'll see it will give us a value error because invalid literal for integer with base 10. But if we said 1, 2, 3, this is what this int function will be expecting. You can see it will just run because it is expecting this data type to be an integer. If we try to maybe give a name, something like Nairobi, this is an incorrect data type. You'll see it will give us a value error because that is an incorrect value for that place. That is an example of how you encounter value error. Okay, because in this instance, the string that you have input there does not represent a valid number that Python is expecting to be input there. That is how you can encounter what we call value error. We said you can also encounter it if an invalid value is passed to a function, or if an incorrect value is also passed to a function. That is when you can expect it. And now to conclude at least some of the common examples of errors that you may occur, we will go to what we call attributes error. To conclude some of the common examples of errors that you may encounter when working with Python, we will have a look at attribute errors. So what is an attribute error in Python, right? Attribute errors, they usually occur when you try to access an attribute, okay? an attribute like a method or a property on an object that does not exist for this type of object, or that does not exist for this type. So it means that Python cannot find the attribute that you're trying to use for this object because it either does not belong or maybe it has been misspelled, right? So let me explain this using an example. It has begun raining where I am, so I hope I'll still be audible. We have a list. 1, 2, and then we have 3. And now we want to append our lists. So we say list dot append, and then we append 4, right? And also we say list dot push, and we say 5, right? The list function has several methods that we can use. It has a list, it has an append method that we can usually use when working with the lists. But this one that I have used, push, it does not exist. It's a method that does not exist. So when trying to use this push, it will give you an attribute error because lists don't have a push method, right? If we say lists dot, you can see we have append, we have extend, we have sort, we have reverse, we have insert, we have remove. These are all methods that we can use in our list object, right? But you see, you don't have anything like push here because that is something that I've just come up with. It does not exist. So if we try to say list push, it will give us an attribute error because lists don't have this method in them. They have other methods, but a method called push does not exist in lists. So it will give us an attribute error and tell us list object does not have any attribute called push. Okay, so that is how you usually encounter things like attribute error when you're trying to call a method that doesn't exist for this object because there are methods that exist. Like you've seen with the list, we have list append, lists remove, and all of those, but we don't have a list push as an object there. So we are trying to call an object that does not exist. So we are getting what we call an attribute error. If we misspell the method or the attribute name, we also will encounter this. For example, if we want maybe lowercase, right? The string object has a method called lower, right? But it does not have what we call lowercase. So if we try using lowercase, it won't work. For example, you say s equals hello world, right? You say that s equals to hello world, right? Now we want this hello world to be in lowercase, right? So we say something like s dot lowercase, right? You see s dot, you see lower exists, but if I continue typing and say lowercase, this method that does not exist. So if I try this, I'll be given an attribute error and told that string object has no attribute lowercase. That is when I'll encounter this attribute error. But if I use lower, you'll see function string lower, it exists. So it can give me whatever I want to appear in lowercase, it can make it work for me, right? But now if I use lowercase does not exist, right? So if I wanted maybe for this to appear in lowercase, so I will say S lower equals S lower, right? Then I tell it to print S underscore lower, right? I tell it to print lower, right? Because I want this hello world to be in small letters, and you can see it will do that for me. But if I just say S lower equals, let's use this lower case, right? Because this method does not exist, it will just give me an attribute error because this object does not exist for lowercase, but for lower it existed. That is how we encounter what we call attribute errors. Sometimes you can also encounter an attribute error when you use the wrong type of object. If you use the wrong type of object, you may encounter what we call an attribute error. So far up to there, I hope we are okay and we have understood the few examples of errors that are common, the common types of errors that we have covered, which are syntax error, type error, name error, index error, key error, value error, and attribute error. There are many more that you may encounter as you continue working with Python, such as import error. This is whereby whatever you're trying to import, it fails to import it. So you'll encounter what we call an import error when a file that you're trying to use does not exist. You may encounter something like a file not found error, and so forth and so forth. So there are many errors that are there in Python, and it is essential to know them because it will make your work debugging easier when working with Python. As you progress to the next level, whereby you will be learning Django, you will require this error handling because it will help you to prevent programs from crashing. We are going to see how we are going to be using the try except blocks shortly, but those will help you to prevent your program or your app from crashing. And if your app is not crashing, you will improve the user experience. As we'll see shortly, it will also make debugging easier. Because if you see a syntax error, you understand it's I'm either missing a parenthesis or a bracket, or I'm missing a comma somewhere, and I can go to where that line is and just fix that instead of wondering where is this error coming from. So it will make your debugging easier, and it will allow you to recover from problems when working with code easily. And as we've seen, we have several types of errors. We've spoken about syntax errors, whereby they occur when your code is being compiled, because it has to the compiler has to read through your entire code. We've also seen about what exceptions are, and we say that exceptions occur during runtimes, and sometimes we have what we call logical errors. So these are bugs whereby it can be due to human error or maybe machine error, whereby it's just not making sense that it cannot execute whatever you're telling it to. So it becomes a logical error when it's not making sense for it to do whatever you're asking it to do. That is when we get what we call logical errors. I'd forgotten to show an example of an exception. So let's do that right now. So for example, with exceptions, I had said we get these exception errors when a program, right, is being executed, and then it occurs, an error occurs during execution of your program. So for example, if we say print 10 divided by 2, right? So if we say print 10 divided by 2 and we run this code, you'll see the code has a correct syntax, so it will pass that stage. Now when it's being executed, it will execute because the program is okay. There are no issues with it that will cause errors to be detected during its execution, right? So when it encounters a situation uh, where it cannot handle the normal flow of execution, we said, for example, if we try this 10 and we try to divide it by 0, right? It will give us a 0 division error because we are trying to divide this number by 0, which is impossible. We cannot divide a number by 0. So it is giving us what we call an exception, right? Because it is encountering a situation where it cannot handle the normal flow of execution of your code, right? So that is what we call an exception. For example, that 0 division error, because you cannot divide by 0, that is when you are getting what we call an exception. That is the kind of an error that you get, what we call an exception. Up to there, I hope we are together. We have covered the basics of errors and exceptions. We were able to define what an error is and what an exception is. We've been able to differentiate and how the exceptions occur and how errors occur. We have also been able to see the common error types. We've seen syntax, type error, name error, index error, key error, value error, and attribute error. And as I've said, there are many others, but these are the common types of errors that may occur. So it is key to understand this so that it will make your debugging easier. Now we are moving to how to the basics of exception handling, where we'll be using the try, the except, the else, and finally blocks, whereby we can exempt ourselves from these errors. We're going to look at that shortly. But before that, up to there, is there any question? If there's any question, don't hesitate. Catherine Mungo has written 0. I don't know what that stands for. Okay, so we are going to move to basic exception handling. So far, there's no question, so I hope we are flowing well and I'm not leaving anyone behind. So what we are going to be looking at next is what we call error handling. Let me share my slides. Mhm. Right. So far, we've understood errors and exception. We've seen that. We have seen common types of errors. We've already seen that. Now we are moving to error handling, where we are going to be starting with the try and accept block. That is what we are going to be starting with when tackling basics of error handling in Python. So with error handling, what that means is we are dealing with unexpected issues that may arise during the execution of our code or our program without causing our code or our program to crash, right? And this error handling is done using what we call the try and accept block, or try dash accept block. You can call it either way, whereby with this try and accept block, you are attempting to run some code within the try block, and if any error occurs, you can handle that error using what we call an accept block, right? So the try block and it contains this code that may raise an issue. This code that you're trying that may bring up an error will be contained inside your try block, right? Then if there's an issue, you'll also have an accept block that will explain to your IDE, your interpreter, or your compiler how to handle this specific error or this specific exception if it occurs, right? So you are telling it jaribu hivi, hii shida ikitokea hivi ndio kadiri nayo. That is what you're trying to do when you're using the try and accept block. That is what we're going to be starting with for now. Then we'll move to multiple accept and the else block. Let us begin with the try and accept block first, right? And when working with this error handling, you should know that this is very important because it helps to make your code more resilient to unexpected conditions, right? Because you're making it more robust, like it's much more strong and much more resilient, that if there are unexpected conditions that occur, it can be able to withstand them, and your app or your program won't be crashing ovyo. It will be giving the user a good user experience because it will be giving them a good or a very informative error message. So because you're using the try and then accept, you also have error messages inside there. We're going to look at that shortly, and it will also ensure that resources are properly cleaned up after use, even when an error occurs. So we've said that we have what we call a try and accept block, right? Let us see an example of how that looks like. So with a try and an accept block, what we do is we have a try. Tunaambia computer, or we're telling our Python program, try, and then we have this code that may bring an error. And then we have the code that may bring an error here. And then we are also telling it except, for example, we are telling it maybe if you encounter what we call a zero division error, like we had seen up here, if you encounter a zero division error, oh, I'm not sharing this screen. Okay, so let me go back and undo. So as we had said with the try block, what we are trying to tell it is we are where we'll have our code that may have some errors. So we're going to tell it here's where we are going to try this code, and then we have to input this code that may cause some errors, right? This is where we input it, code that may cause some errors or some exceptions, right? And then we tell it except, right, the kind of error that we are expecting. So let us use a zero division error as we had seen above. So we are telling it zero division error, right? And then we're telling it what will you do if you see a zero division error. It prints that. What will it print? It will print that we cannot divide a number by 0. Right? So this is what we are doing with error handling. We are using a try except block, whereby we are attempting to run our code. We are trying, that is, we're using the try block to run our code inside there. And if an error occurs, right, you can handle that error in the except block. For example, if you're running our code inside here and we get a zero division error, this is what you will tell this person. Instead of crashing the program, you tell this person cannot divide a number by 0, right? So essentially that is it. The try block will contain the code that could have some errors, and then the except block kazi yake ni kushika hizo errors and then inazihandle. Instead of making the program stall or not work, it will just print a message like you cannot divide a number by 0. That is how the try except block work. Up to there, I hope you're following and I'm not confusing you. So we're going to do an example whereby we will use this division error. So we are going to say try. Let me just clear it all. Try. Then we say num equals to 10, right? So we have a variable called num, and then we say result equals num, and then we divide num by 0, right? So we're going to be dividing our variable, our num, by 0, so that we get a 0 division error whereby it cannot be divided by 0. So we give it an except, right? We're telling it we expect a 0 division error inside here. That is what we are telling it. We're expecting a 0 division error. And how will you handle this 0 division error? You will print you cannot divide by 0. And then we can even add an exclamation mark for flair. Okay, so when I try to run this, right, if num divided by 0 is attempted, of course you'll get a 0 division error because you cannot divide by 0, as we had seen that's an exception. But this 0 division error, it won't just give us the error message like it did up there. It will be caught, this error will be caught by our except block, and it will give us this message that we have told it to give the user. It will give us this message, you cannot divide a number by 0. You see, you cannot divide a number by 0. That is what it will tell us. And like up here, where it will just tell us 0 division error, division by 0, just tell us that. Here it is a much more nice way whereby you have a better user experience, because you are being given information or an error message, the program is not just crashing. You understand that this is where the error is coming from. Unlike up here where we had just the zero division error, whereby no matter how many times we tried to run this, it just come to a zero division error and tells us division by zero. There's no way forward, so we can't understand where we're making our mistake. But if we are using a try except block, you see we are trying to divide the same number by zero, and because we are expecting that issue that was appearing here, we have an except block to handle that error and explain to us, give us an informative message that you cannot divide a number by zero, which means that this is where the error is coming up from. Up to there, are we together? Okay, thank you. I see we are together. Is there a question? Yes or daddy? Yes. Is there any question?
Yes. I was asking,
Yeah.
this particular except try block, I saw you typing it there. So which means you type it there and then it is going to function for you, or how do you put it there?
The except block.
Mm.
Okay, let me explain. We are using what is called a try except block, right? The primary purpose of the try part is like testing. You're testing a code for errors. So that part we are done with. We understand that we're using the try to test this code for errors. So when we're testing it for errors, we know that an error may occur. So we are using an except clause, okay, whereby we are expecting a specific error to occur. This kind of error to occur. If this kind of error occurs, this is how it handles it, by giving us maybe a message or explaining to us why this error is occurring. So for example, after we've written our try block, we have our except clause, right? So our expect clause in a specify any particular type of error that may occur. We have seen the examples of errors, okay? Or any particular type of exception that may occur, and tells you how it will handle it. So if the system encounters this kind of error, it knows how to handle it or what message to give to the user. Am I clear ama na confuse hapo?
You are very clear, but what I was asking,
Yes.
so which means in your coding space, where do you locate, where do you install it? Unaweka hapo kwa the code space ama
Yes.
una
Nimekupata.
yes.
You're the one who writes it. You see, with this try except block, it's error handling. You're trying to minimize errors in your code. So you have to write an except. You can write as many excepts as possible. For example, for the kinds of errors that you're expecting. If you're expecting a zero division error, an index error, you can write the except for those errors and tell the program that ukipata hii error ruka hiyo, ukipata hii ruka. We'll see how you can do it for multiple errors, but when unaandika that part, you're the one who writes the except block to find to catch if this error occurs and handle it. When unaiandika hiyo part, ndio program yako isi crash. Unacheki kama hapa tumesema print 10 divided by 10, right? Nikifinya run inaniambia tu zero division error, like program yangu haiwezi endelea. There's nothing more I can do because I have an error and maybe I don't understand kwa nini hii error inatokea. So hapa tuwakam tukasema tujaribu tuone. It is the same two code, it's just this 10 divide by 0. Basa tumesema ukipata hii error inaitwa zero division error, we ambia huyo mtu that hawezi divide number by 0, ndio ye aelewe kwa nini error inatokea. Si ati error inatokea tu hivyo, ni ati ni vile amejaribu kudivide number by 0. So ukimpea hii except block inamwambia tu like this error is occurring because you have tried to divide a number by 0, badala tu kumpatia tu an error without explaining what is causing the error. It may make sense.
Yes, you're making sense. You're making sense. But mi naona coding space, naona working space bado iko, lakini bado hii you can as well get hii try except block, lakini working space yako naona iko pale juu, lakini hapa chini ndio nakuuliza hii una install hapa chini. Hapa chini na ano how umeiweka aje hapo chini? Hiyo ndio kitu tulikuwa nataka kujua, because naona working space yako bado iko.
Nimefungua whatever I'm using is a different kind of IDE, ndio ina allow create multiple, but let us just do maybe index.py. Index 2, I already have another index. Okay, so kama hapa nikisema 10 divide by 0, niseme print then niseme 10 divide by 0, si ndio? Nikirun hii itanipea hiyo error tu kawaida kama hiyo ingine. Ndio hii nipea hiyo error, niambia zero division error. But sasa vile tumefanya tumesema ni copy tu bila kutype tena. Hapa tumesema hivi, let me just type, there's no issue. Tumesema try, so we are trying our code, so we are saying num equals 10, right? Tunasema sasa hapa num equals 10, then tuseme result equals num divide by 0, si ndio? So hapa we can just say print result. We can just say print result na tufunge hii chapter. We can just say print result na tufunge hii chapter. We can just say print result na tufunge hii chapter. But now instead of that we want to accept, because we had already divided this 10 by 0 and we got an error. So we want to accept this error. So tuna type tena accept, then we write the name of the error that we got above there. We say we got a zero division error, right? Now, if you get a zero division error when you try to run this, unafaa uambie mtu the reason unapata hii zero division error ni kwa sababu you cannot divide a number by 0. So inamprintia you cannot divide namprintia hivi, like hii part itakuwa kwa program yako. So for example, if it's a number guessing game whereby ama a calculator that you are creating, and in that calculator someone tries to divide a number by 0, sitapata hii zero division error because you cannot do that. So akipata hii zero division error, instead of hiyo game kama hiyo calculator yako kumtosha tu sasa haifanyi kazi juu unapata hii error, you can add something like this, a try except block inside that calculator of yours, whereby when they try this and they get that zero division error, inamprintia something kumwambia the reason unapata hii issue ni because you cannot divide a number by 0. Na akiran itamwambia tu you cannot divide a number by 0, itamwambia tu hivyo. Ni hivyo when unaandika, when unaiandika sasa una install, it is you who are writing, who is writing it.
Understood now. Understood.
Okay, thank you.
Maybe another question, but maybe you'll answer me later. Hello?
Hello, I can hear you.
When you want to leave this particular working space, because hii working space yako sasa unataka kutoka, can you show me the icon man when you utaenda? Now you want to leave that particular working space and you want to go home in this particular working working space. Where is your home in this working space?
My home. I don't understand.
And now you want to close this particular. Sasa umemaliza ama unataka kurudi nyuma, isn't it? Unataka kurudi nyuma kwa hii sasa, unataka kufunga hii working space. Kuna is there an icon hapa ndani kwa hii working space yako ambapo where you tap it, alafu baadaye ufunga hiyo nini? Oh, you just unaenda tu kwa button uko bado.
Unaona hapa kuna X.
Yes.
So sawa, kama hapa inafunga. Nikifinya hii nyingine inafunga.
I've seen. Thank you.
Okay, welcome. Okay, so with the try block, we are okay, all of us. With the try except, I mean, we are okay, all of us. Or I give another example. Okay, let me give another example so that we see how we are dealing with this. So we try. What should we try? We try enter a number game. So let us try. We say user input. User input equals to input, and then what do we want them to input? We want them to enter a number. We want them to enter a number. Right, so we want them to enter a number, and this number should be an integer, right? So we say number. So we want to try maybe a value error. We had seen how to bring up about a value error. Number equals to int, and then we have user input, right? So number equals to an integer, and then that integer is equivalent to the user input. And since we are expecting a value error, we come here, we write our except block. Except what kind of error are we expecting? A value error. We're expecting a value error. We're expecting a value error. And when we encounter this value error, what do we print? We'll print that this is not a valid number, or we'll just say that's not a valid number, like that, right? You remember when we were talking about what a value error is? Can anyone do a recap of what I said a value error is?
A value error is it captures user inputs when they enter something of a different data type than the one that is expected. Say when, like the one that you've said, the number, if they input a text, it will say that's not a valid number.
Good, correct. So yeah, that is what I had said. Thank you. I said that a value error will occur when a function receives an argument of the correct data type, but with an inappropriate value. So here, integer, we are expecting a number, and then if we maybe get a and a string instead of an integer, we will get what is a value error in our example here. So we try and see what will happen when we run this code. Please enter a number. Okay, let's enter one first to see. No error is occurring because I've entered the correct number. Let's try again. Let's enter hello. You see, it tells me that this is not a valid number. Are we together? You can see what I'm doing. Okay, let me run it again. You see up here, a pop-up is appearing up here. It's telling me enter a number. Right, so if I put, let me put even 1000. You can see I've written 1000. When I press enter, it will just give me a tick, meaning that I'm doing the right thing. But if it asks me to enter a number and I write that 1000 in words, let's say I write 1000, you see, and I click enter, it tells me that is not a valid number because I am trying to enter a string which is caught with our except block. I'm not entering an integer as it expects, so I'm entering a string which is in a numeric string to be specific, which is not what it is expecting. So it moves on to the except block and just giving me a message telling me that is not a valid number because that is an numeric string. If I put 1, 2, 3, that you see, it will understand that this is the right value that is expected for there. So that is how you can use these try except blocks to catch your errors. So for example, if this user maybe nimsewa or let's say it's someone who is illiterate and you want them, maybe this is a system for a bank or something like that, maybe an ATM, and they want to withdraw their money, right? So you're telling them enter the amount you want to withdraw, right? And if you've ever seen how that keypad looks like, it looks like that one for a small, like a Tululu. It has ABCD, number 1 has ABCD, and you know how that looks like. So this person, maybe he's used, if you type, you press on maybe number 2, 2 times, it goes to letter B. So maybe they try to do that and then they write for you, I want maybe 50. Instead of writing the number or the amount of money they want to withdraw, right? Instead of this crashing your system, it just gives them that this is not a valid number, right? So that they understand that what I've input is not a valid number that is expected by this system, that I can try maybe and input a valid number. If I say maybe that 50 that I want, it will just work and withdraw for me whatever amount I want. You get that explanation for why you can use such try except blocks in your code.
Yes, but this is out of context. But how are you able to type? Can you type like a number? Can you type an input? I saw you typing something.
Yeah.
How are you doing that?
Oh, okay. So I'm using Python notebooks. It's instead of using the okay. Let me clear this so I explain that. I'm using Python notebooks. It's just like Jupyter notebooks. You remember that when we are working with Python files, we have something like index.py. We have the py extension, right?
Yeah.
But now you see this one that I'm working on has an IPYNB integrated Python notebook environment. So it allows you to work with Python inside. It's like it's for the data science and data analysis, whereby you can do whatever you're working on inside it. You can write your Markdown files to explain whatever functions you're doing and all of that. It's good for working with Python. So that's what I'm working with. It's much easier instead of opening my terminal every now and then. This is much easier to teach with.
Okay, so you're just using Visual Studios, but you're saving it in IPYNB. Dot
Yeah.
IPYNB.
Yes.
Okay.
Okay, thank you. So up to there, I hope we are okay with the try except. Unless come on, anybody has not gotten the try except block, we can go over it one more time, because now we want to go to we have seen the try and except block. We now want to include the else and the finally as we conclude. But the other things, so we want to go a bit fast for the remaining part. So I hope up to there we are together on the try and accept block. I've not left anyone behind. So as we've seen, the try except block, that is the core. When you're doing error handling with the try and except block, you'll be using that as the core for your error handling. And you can enhance it whereby you can either have multiple exceptions, whereby you can have multiple excepts, or you can also use the else and finally. So first we will see how to handle multiple exceptions, and then we also see how to use the else and finally, and we can see how to raise a throw catch before time ends on our side. How to raise a throw catch. So when we are handling multiple exceptions, it's just the same thing that we are doing here. So for example, we say maybe try, let's do something, another one here. We say try, right? Then we say number equals integer. Then we want input, and we want this input to be enter a number again. That is what we want our input to be, enter a number. And then we say the result will be 10, right? Divide by this number. 10 divided by num, right? 10 divided by this number. And then here we say print this print these results. The result is result, right? So we want to print the result is a result, like that, right? And then we want to use multiple excepts here. So the first one, what will we expect? We expect a value error. A value error. Then we'll tell this person, we'll put our message print, you did not enter a number, right? You did not enter a number. Yeah, did not enter a number. Then you remember this 10 is being divided by a number. This person can also put a 0 as the number. So we can put another except here, whereby we are expecting that 0 divisional error, whereby when you try to divide by 0. So here we tell them print, we leave them a message, you cannot divide by 0. Okay, so this is how our example looks like. So we are trying to handle more than one type of exception right here. So we can use multiple except blocks when you're trying to, you can either use only one like we are done above, or you can use multiple when you're handling more than one exception. So as usual, the try block here, it will handle the conversion of a number input into an integer. and it will use that number, divide it by 10, and then we'll get our result. So the value error that we are expecting here is when this person tries to enter to enter data type that is not the numbers that you're expecting. So that's when they'll get the value error. If maybe they try to input in words 50 or 1 in words instead of the actual figures, so that is why we're expecting the value error. The reason we're expecting a zero division error is if this person tries to divide this number, it gives this number as a 0. So it will try to divide this number by 0 and we may get a zero division error. So you see, those are the kinds of errors that we have thought through, and we are expecting them to come up with our code. So here, when we try and run this, it will tell us up here, enter a number. So let us start by 2, right? If we enter 2, it gives us the result is 5. No error because we have input an integer. So we have not gotten a value error. And this integer has been divided by 10, so we have not gotten an error. And we have not input 0, so we have gotten our result. If we try again, minimize so that we can also see up to the result. If I try again, and now I put 1 in words instead of the integer, the number 1, you see, it goes to the value error. And what will you tell me? You did not enter a number. So I'm getting that error. It has already thought through that this is what I've done, and this is the error I'm getting. Instead of crashing my program, it will tell me the value error. If I try again, and this time I enter a 0, it will tell me you cannot divide by 0. So I can use these multiple try and except blocks. I can use multiple exceptions to handle multiple, more than one type of exception that I'm expecting in my code. So in this case, I've handled all the exceptions that I may expect in my code. So here, the only option that is remaining is maybe if I just, let's say 3. You see, it will just give me the answer because this is the correct. I've not put anything that goes to a value error or anything that goes to a zero division error. So it will give me the answer in my code. Up to there, we are together. I hope so, because I can see time is also going. Let us also see how to now use the else and finally with our try and except blocks. So we want to see how we can also use the else and finally in our try and except block. So this else and finally, let's first start with else. So the else block is what will be executing if no exceptions occur. So in our example, we've seen above in our earlier example, when we have not gotten this or this exception, it has given us the result, but it has just given us the result, but we can use the else, whereby it will just continue when we don't, none of the exceptions that we have input in our code occur. It will just give us our else. Whatever we input in our else, it will just give us that. That is what the else block is. And now the finally block, that is the block that is always will always be executed. Whether an error occurs or not, the finally block will be executed. Hicho ni kama unaiambia jaribu hii, ukipata hii error fanya hivi, ukipata hii error fanya hivi. Kama hakuna hii error ndio unaambia else fanya hivi. But finally ni kuambia whether upate error, whether usipate error, liwe liwalo, just do this. That is the finally block. It is used to perform cleanup tasks. Kama unataka kufunga hiyo file ama ku release some resources kama RAM. So if this program is, maybe you're trying to input your pin and you're encountering the first except, you're encountering the second except, you're also encountering the else and maybe it's not working and unashinda kurudia the same thing. So finally inasema tu ukipata error, usipopata error, wewe maliza hii kitu ufunge hii task. That is what essentially means. It will always be executed whether an exception occurs or not. That is where the finally block comes in. So before we do a complete code with the try, except, else, and finally, let us do one with try, except, and else. Actually, we can just build on whatever we have. We can build on whatever we have. We can build on it. Yeah, we already have this one. We can build on it. Let us just copy it instead of writing another. We paste it here. So this one we have our try. So we are trying. We input our number, and then the result will be divided. Will be 10 divided by that number. If it's an invalid data type, we will get a value error. If it's the number is 0 that is input, we will get the 0 division error. Then here we can add now our else block. We can add our else block, whereby we just type the name else, and then we now print what we want it to do. So we say print, and we use an F string, and we say the result is result, right? Like just like here. The result is result, and we will remove this one here, so that it's just like, so that we have the except block working and the else block working here. So it's the same code as above. Now you see the way it was giving the result here is because we had this inside here. But if we did not have it inside there, let us first comment out this so that we see when you try and run it, we see what would have happened. Just the above without the string, enter a number, we say 1. That is the value error. You did not enter a number, that one works. Then we say 0. We get the 0 division error. You cannot divide by 0. What if we put a correct number? We see without that line of code that we had with the F string, it will just give us a trick. It won't run the code. So that is where the else part comes in, whereby this code will be executed if none of the errors or none of the exceptions occur in our try block. That is where the else will come. Here we had already just input it here, but that was just because we wanted to see our code working. But now we want to see how we incorporate it as an else block. So we are saying try this code like this, right? If this person does not give us an integer as a number, we get a value error. So tell them did not enter a number, right? If they give us 0, we get a 0 division error. So we are expecting that. So we are telling them, tell them you cannot divide by 0. But if they print anything else that is an integer and is not 0, then use the else block and execute the code. So if we try, let us work with the value error. We say, let us try 1. You see, it will go to whatever happens after the value error and gives us a message, did not enter a number. Now, if we put a number, we put 0, it goes to the 0 division error and tells us you cannot divide by 0. But if you give it a correct number, which is not 0, it will now run the else block and give us the result. You've gotten that part. That is how the else block works. And now we have the finally block. I want us to try the same, but this time I want us to use okay, so we will just use the same code. I'll share, let me also share this so you can try it on your end. Okay. So I'll just use the same code, but now I want us to use finally. So we are trying, input a number. Okay, then here we will remove this. So because we don't want to divide this number, so let us remove the zero division error, and we remove this part. So we try to get a number input, and then when we get this number input, we want to tell them what number they gave us. So print the number you entered is number, right? So num equals for them to input a number. So we want it to print that whatever number they entered is this. If they enter 5, want it to give them 5, right? But if they not give us an integer or the character type, we want for them to get a value error, whereby it will print for them. It will give them a message, you did not enter a number, right? And then in our else here, we want it, if they just give us whatever they give us, we want it to print for them, you entered a valid number, right? So we want to tell them you entered valid number. You entered a valid number. Some flare there. And then now we use the finally block. Finally. And then here, this one will just print this code runs no matter what. Okay, so this code will run regardless. So like we had explained before, with our try block, what we are trying to do, we are placing a code inside there that may bring an exception or an error. So in our case here, we are trying to convert our user input to an integer. Then our accept block is a value error, whereby if this exception occurs, if in the try block up there, they try to input something that is not an integer, they will get a value error. And this value error will be caught here, and they will get this message, which will tell them you did not enter a number, right? Then in our else block, this block will run if this error does not occur. This is where this block will run. If this error does not occur, then it will just run and say you have entered a valid number, right? And then finally, this will run regardless of whether this error occurs or not. So let us run it. So let us first give it an integer input. It tells us you did not enter a number, but you see the finally also runs. It tells us this code runs no matter what, right? That is how the finally will just run regardless. So if we run it again and we give it a number 1, right? It will tell us you entered the number 1. It will tell us the else you entered a valid number, right? And it will give us the finally your code runs no matter what. Up to there, I hope you are seeing. It will give us, so this code that we're trying to run in our try is to get the user to input an integer or a number, right? So if the user inputs a number or inputs a data type that is not a number, they will get a value error. So that's where the except block tries to get that error, and it tells them it did not enter a number. If they don't get this except block, it will just run and tell them you entered a valid number. But now we have the last part. This just, the code will run regardless. It won't break your code. it won't crash your program. So as you've seen, if I enter 1, the number will show. The number you entered is 1. The else statement will go. You entered a valid number, and finally this code runs no matter what. But if I say maybe 50 or 5, let's say 5, you see, it will get the value error and print for me that message. You did not enter a number, which is true. And then it will, because the else will only work if there's no error, it will go to the finally and tell me this code runs no matter what. That is how the finally block works. Up to there, we are together. So we've seen basics of error handling. We've seen how to do the try, the except, the else, and the finally blocks. We've seen how we catch exception using the except blocks and how to handle them. We've seen the order of execution in the except blocks with that final example. We had seen how to handle multiple exceptions, whereby in this example where we had multiple except blocks, we can conclude with how using arrays to throw an exception. Let us conclude with this, and then I'll share this notebook in the group there with all of you. So let me also share this try else and finally in the chat. These multiple exceptions. This is the try and except alone. The first example. And then another try and except example. Let us conclude. We conclude with using arrays to throw exceptions. That is what we are going to be concluding, unless there's any questions so far. We are together. So with this raising an exception in Python, we can raise exceptions. We do this intentionally by the use of the raise statement, right? So raising an exception allows you to create a condition or a custom condition for an error to occur in your program, which can be used for validation or to enforce certain rules, right? So this is usually useful when you want to specifically indicate that this error has occurred in your program and it needs to alert the user on to handle it, or to alert the user or to call the function so that you can handle it. We use them to enforce validation and to handle error conditions, and also to create custom exceptions. That is why we use the raise exceptions. And the raise statement can be used with a specific exception class or with a custom exception class. So for instance, we can use it with a specific exception class or a custom exception class. Like for this one, raise exception, error message, right? So the exception here is the base class for all our exceptions in Python, and the error message is what the message that will appear in association to the exception that has occurred. We will do one example because time is not also on our side. So what example we use? The check edge. Let's use the check edge example. So we define check underscore edge. Right? Then we say if edge is less than 0, we raise a value error. So we are using the raise. We are using the raise to throw an exception. So for this one that we are trying to throw here is a specific exception. It's not a custom one like the example that I had shown, whereby we had said raise exception, error message. So this one is a specific exception. It's not a custom exception. So we are raising a value error. So this value error will be age cannot be negative. Right? It will show us that the age cannot be negative, and it will return the age. Then here we are going to have our try block. So we say try, and then we say user age, right? We say user age is check age. Then we want our input to be an integer. Enter your age. Enter your age. Right, we want our input to be an integer. Then we tell it to print. Let's use an string. Your age is this, and then we get this user age. User age. So that is what we will get here. And now we have we will have an except block here. Except block for value error. In case this input is not an integer, value error, and then we say and then we tell it to print this E. So in this code of ours, the function check age that we are using, we'll use it to check this age. So what it will do, it will check the age it will input. If this age is a negative number, for instance, if this age is negative 50, it will raise a value error with the message age cannot be negative. So you see that we have used raise to throw, we have used the raise statement here to throw an except, you've used it to throw an exception, because if this age is negative, we will get a value error telling us that age cannot be negative. Okay. Then in our try block, we have an except block there, whereby the exception that is in the except block is what will have occurred up the value error that will have occurred with the raise exception. So it will be caught down here in the except block. The value error will be caught here, and the error message will be printed. The error message that age cannot be negative will be printed here. So let us try that. We run it. Then we try and input -5 as our age, and we enter. You see, it tells us age cannot be negative. If we try to input age -5, it tells us that age cannot be negative because this raise value, this raise statement that we have used here, throws an exception. So we are manually raising exceptions. Instead of coming to write all of this here, we have already written it using the raise statement up here, and in our except block here, it will just print this statement that age cannot be negative. But if age is okay, if I say 10, it will just say your age is 10. So it will print whatever is in your try block. So that is how you use raise to throw an exception. You're using the raise statement to throw an exception. You can also work with custom exceptions. So you are creating your own exceptions. That is, when you're working with custom exceptions, you will be creating or throwing your own exceptions out there. And these exceptions will be user defined. So the fact that they will be, these custom exceptions, they will be user defined. So you will be the one who will defining your error conditions. So these error conditions will be specific to your program. Whatever your program is doing, this error condition will be specific to that. So by creating custom exceptions, you make your program's error handling more meaningful or more descriptive, which will provide better control and clarity when someone goes wrong or when something goes wrong in your code. So that is where you will be working with custom exceptions. There were some exercises that I was to give us to conclude with or to work with to make sure that this concept of error handling in Python is well grasped. I can text them in the group so that we can all maybe attempt them and give an answer. We see if you're able to understand how to work with this error handling that we have learned today. If you're able to handle multiple exceptions, if you can use the finally in your code for cleanup, or how you can use the else block. We're supposed to do some exercises to help us with that, but I see time is gone. Time is not on our side. So unless there's any question, we can stop here. Is there any question?